We are still waiting for a few students, so be patient. And you can see the list of the finalists today. Okay, so I think we should start now. So welcome, inventors and innovators. Welcome to the IFIC International Judging Circle. It is also the ICIA Innovation Award final pitch. Here is the all of the 11 groups of our finalists. You can take a look. Congratulations to all of you. So you are the inventors and innovators of the day. And I think the whole world cannot wait to see your innovation ideas. So let's have a look at it. And you know, the session is live streaming. That means the whole world is watching you right now. Are you excited? Okay, so let me first show you a short video about all of the finalists today and their work. Wow, so excited. So these are the most important people today on this stage to celebrate this great event together. And before I introduce the judges, let me briefly introduce myself. I am Vera Song from IFIC China, and my partner, lovely Lisa. Can you say something to our participants?
Hi, thank you, Vera. Hi, everyone. I'm Lisa Stephanie from Korea, Indonesia. Both of us will be moderating you for today. So it's really nice to see all of you sharing. All the best, everyone.
Yes, great. Thank you. Now, let's warmly welcome Mr. Jake Madison, the director of the Invent Future Global. Let's see, what is he going to say to all of us?
Hello, everybody. My name is Jake Mendelson, and I am the International Director for InventFuture.global. I am very, very happy to be talking to you today. But I am even more happy about all the wonderful things you are doing. This is a wonderful event, and you are getting a chance to demonstrate, to show, to explain your creativity, your innovation, your inventiveness. Congratulations to all of you. I can't tell you how proud I am of the wonderful things that you are doing. Now, as nice as that is, I want you to remember that this is just the beginning of your life of creativity. You will be doing wonderful things in the future, and I am glad that this event is part of that experience for you. In 20 years, you will not remember me, and you will not remember this little talk that I'm giving. But you will remember this event, and you will remember what you did here, and you will remember that this was the beginning of your creativity, of your journey to being an inventor, to being an innovator, to being somebody who will change the future. So I want to congratulate all of you for being here, and I want to congratulate you for the wonderful things you've done today and the even more wonderful things you'll be doing in the future. Good luck to all of you on this wonderful journey.
Thank you, Jake. So let me introduce the agenda of today. So judge self-introduction. We're going to meet our judges soon, and then followed by the review of our pitch order. And then it's your pitch time. After that, our judges will go to another room for their review. And you can say goodbye to the judges and other teammates. Okay, so let's warmly welcome our first judge, Wu Zhiyuan from China. Hello. Hello, Mr. Wu.
Hello. Can you hear me?
Yes, we can hear you, but we can't.
Okay. I'm from Nokia. I'm an expert in telecommunication and signal processing algorithms. I got my PhD from Canada. That's all.
Thank you, Mr. Wu. And we are looking forward to see our lovely students today. And let's welcome next judge, Mr. Karthik from India. So
hello.
Mr. Karthik?
Yes. So happy to see you all. I work with the Ramakrishna Mission. I'm in New Delhi, which is the capital of India. And I've seen all of your projects, the logbooks, and I'm very excited and looking forward to listening to all of your pitches.
Great. Thank you, Karthik. Next one, our beautiful Khulud. Welcome.
Thank you, Vera. Hi, my name is Khulud Ghanem. I am originally from Syria, living in UK. I am the co-director of Discover STEM Education now and the director of Kids and Code, which are both educational organization in the UK and in the Arab world. And I'm so glad, so honored to be here and ready to listen to you. Good luck.
Yes, thank you. Thank you for coming, three lovely judges. Now I'm going to show you the list of our pitch today. So the first one is the Smart Masker Reminder. The second, Air Conditioner Water Harvesting Project. The third, prototype of device that recognizes car crashes and risks for hydroplaning. And number 4, water hydrophobic wallpaper as thermal insulator. And number 5, STEM project Black Soldier Fly Compost. And number 6, automatic irrigation system based on the soil moisture indicator. And number 7, employ. And number 8, carbon dioxide capture system for modern greenhouse cultivation. And number 9, Drax tofu meatball. Looks yummy. And number 10, pectin extraction from pelago peel to reduce sodium alginate in sulfurification for hypertensive patients. Wow, that's really professional. I cannot really read it. And 11, geothermal monitoring application with light distance and region technology, Geosol. Okay, so these are the orders of our pitches today. And now, let me show you the rules of the judging circle today. Always mute yourself when you're not speaking. You don't have to share anything. Just focus on your presentation. And I know some of you are going to share your PPT, and that's okay. And then keep your video on and inform the moderator you're going on. And during the Q&A section, each judge will be invited to ask questions in turns. Students can also raise questions using the chat window. If you have audio, video, or other issues, use the chat window to inform all. We can adjust your presenting sequence so that you will have plenty of time to fix your tool issue. Okay, let me stop sharing for a little while because it's the screen time. Let's take a selfie together. So everyone, turn on your camera. So I invite everyone turn on your camera. We are not smiling yet because we're still waiting for everyone to show their lovely faces.
Okay.
Okay.
We have 2 pages here, Farah. So yeah,
Can you
hopefully
see?
everyone can turn on your camera and
Can everyone
take
turn on your camera? Yes, we'll take a photo before the pitch begins.
Yes.
Yes.
Okay, thank you so much for turning on your camera.
Yes.
Okay.
Wow.
So I'm
We
going
have
to
faces full of screen.
yeah,
And
right.
Natalie, Natalia, Amelia, and someone else. Could everyone turn on your camera? Okay. Okay, so wow, great. So we are going to take several shots first. Shall we, Lisa?
Yes.
Okay.
I'm going to take.
So we'll take the first one about smiling and then we'll give some gestures, right? Okay, smile first. Everyone, 1, 2, smile. Great. Oh, I see the thumb. So the second is to showing the thumb. You are the best. Great. Okay, so that's our second photo. Okay, thumb up. 1, 2, 3.
Okay, it's already taken.
Okay, thank you, thank you. So let's go back. Okay, so I'm going to remind you about the time. So maximum, each group is going to have 4 minutes presenting time. That is your live pitch, maximum 4 minutes. If there's 1 minute left, that means you still have 1 minute. I'm going to remind you with the bell. Okay, so that means you have 1 minute left. So if 4 minutes is up, you will hear. Okay, so that's the constant sound of the bell. So after you pitch, you're going to have 5 minutes Q&A session, and then we'll leave 1 minute for all the judges to fill out your rating sheet. Okay, is that clear? So I'm going to move on to the first one, smart mask reminder. Okay, from China. So are you going to have the slide or you don't have to use the slide?
We don't.
You don't have to use the slide, okay?
Shall we start?
Yes, I think you can start now.
Okay, let's go.
Hello, everyone. My name is Chen Qingyu.
My name is Ding Silu. My name is Duan Yixiu.
Our invention is called the Smart Mobile Wearing Mask Reminder.
Okay.
And this is Piper Computer. It's a smart mobile computer.
Yes. 好，想展示一下。
Then let's show our invention. This is infrared diffuse reflection sensor. It can injection and receive infrared. And this is LED. It also can remind people. If someone walks up on it, it will transmit a signal to the computer.
Like this. And start.
If there's someone behind the sensor, the Piper computer will turn on the LED. Also, remind people to wear the mask.
and the people will wear mask.
继续讲，然后这个有什么作用？
It can remind people to wear masks.
We make it because we want people to wear mask, and the worker is not.
And we make it easier for workers with machines. We use the sensor to sense and then voice reminder.
By themselves.
And everyone can take it by themselves.
好，那就结束。Thank you.
Thank you.
Okay, lovely. So that's our first group of pitch. Now, let me welcome our lovely judges to ask you questions. So first, can you ask the question first, Karthik?
So how did you think of solving this problem?
就怎么解决问题的？
We ask teachers and our classmates,
Parents.
and parents. Yes.
然后呢？
And
Also, we looked
use the
for
internet, of course.
然后我们6年级上拍本课，
and we have Piper lesson in grade 6.
然后学习编程 learning coding。
And
To
we
learn
learn how to use Piper code to do something.
然后这个语言编程语言叫做谷歌 Google Block， 翻译一下 ，the coding language
The coding language is called Google
Blocking。
Blocking. Thank you.
yes.
Yes. Yes, thank you. Thank you. So let's welcome our lovely judge, Claude. Any questions for this group?
Yeah, they answered my question. What language did they use? But I have another one. What kind of sensors you said you have used?
We use infrared diffuse reflection sensor.
Wow, that's so advanced. Well done. Looks amazing. So complicated job, and the coding, the electronic part. Oh my God, this is really great. All different components.
We use
Great.
a lot of sensors, yeah. And we choose the best one is this one. Yeah.
Oh, so you have tested different sensors and choose the best one you thought it's gonna fit to your device. Perfect.
Yes.
Great. Well done. Thank you.
Thank you. And next one, let's welcome Mr. Wu. Do you have any questions for them?
Yes, it's very complicated invention. I have only one question to ask. What did you invest the market value and something like that?
最有价值的
Market value.
市场价值，就是如果你要把它卖掉的话，
How much does it cost?
花多少钱？买
Uh,
它的话，
like
$450.
Okay.
maybe more because this Piper computer maybe cost 2,000 RMB. So this invention maybe we 2,100 RMB.
Okay. Just okay. That's what I want to know. Okay.
Thank you.
Okay, great. Thank you. Any other students, if you would like to ask the participants today about any questions, you can leave the message in the chat room. Okay. So it seems that there's no other questions. Thank you, Group A. Thank you. And then it will be 1 minute for our judges to write on your rating sheet. Okay. So let's wait for 1 minute for our judges to note down anything on their rating sheet. Thank you again.
OK，那我们静音了。啊，
我可以走了吗？
等一下。好，下。
Okay, project 2, get ready. It's the air conditioner water harvesting project. Okay, let's welcome. The second group. Yeah.
Cannot start screen share.
Yes. Do you have any slides to share? Wow, here we go. Lovely. Yes, you can start now.
Assalamualaikum and hi everyone. We live from Malaysia. I'm Nur Zero Merah.
I'm Tan Hafifah Samia.
And I'm Muhammad Aswadi. Within these 4 minutes, we will present our innovation.
Sit back and stay tuned.
We know that water is one of the important resources that life will not be possible without it. Thus, this is the reason we must take care of our water resource. Did you know that water scarcity affects more than 40% of people around the world and is projected to rise? That's why it will fix through SDGs Goal 6 by 2020. So, we come out with this idea to expand our water reserve by using alternative resource, which is reusing water condensed from the AC with AC water harvester.
If we turn on the AC, we have a source of considered as grey water from the AC greenhouse. Although it isn't served for drinking, it's still a water that we can use. We can use AC water harvester to collect the AC water content and reuse it to the garden or other uses. Each product only have 3 main components. First is the collector. It used to collect the water directly from the AC. Second is the pipeline. It used to channel the water to sprinkler. It also equipped with a tap to control the water flow. Third is the sprinkler. The mechanism is simple. The collector connected to AC greenhouse. The pipeline will channel right to the garden. The collector will collect the water right after the AC turn on and to use it. Just open the tap and the rest. Let the system do their job. It's easy to handle.
Starting this project is from problem-based learning on SDGs, whereby we did the observation in our school. We found a few AC outdoor unit projects. Wastewater and the water usually send the drain. We did the observation systematically by using problem observation chart to identify the issue in our school. This chart used to choose the main issue related to SDGs to solve. Later, we continue our discussion using SDGs brainstorm work to find the solution. And finally, we got the prototype to test. We did a few tests and made some adjustments. The most importantly, we use items that we can find in our school. So it is zero cost product. We want to show that although using regular items that we can find easily, we still can produce something useful. The impact we got: first, the problem of scarcity of water can be minimized. Second, can save water consumption. Third, can save manpower. Fourth, this great tech with no advanced equipment required. Also, it's easy to handle and it can save our pocket money.
Lastly, we hope for this innovation we can see the product potential to ease our life, although still have room for improvement, but the idea and effort is there. We expect through this innovation we can contribute something to the SDGs. That's all from us. Thank you.
Thank you. Lovely. Okay, I like your presentation. Like each one takes on different role in one by one. So are you ready for the judges asking questions? Yes. So let's welcome Mr. Wu first.
Okay. It's I think a good image. How did you find the air conditioner may have some water? How did you find this? The water can got from air conditioner.
Okay, sure, of course. Observation charts. Simple say, this chart is tool of us to identify the problem of observation. Usually, the chart directly relate it to the SDGs. So we know which problem cover which SDGs and the most covers SDGs. We take as a main problem.
Okay.
Okay, thank you. Oh, go on. Yes. Yes, please. Yes, you can continue. Sorry for that.
Yeah, sorry to interrupt. You can continue. If have anything to say?
That's okay, right? Okay, great job. Thank you. Now let's welcome Ms. Karud. Any questions for them?
Yes, we had this problem back when I was in Syria, like 10 years ago. When we had electricity, we always got the air conditioning leaking water in our balcony, and we had to put a bucket, collect this water and do something with it. You guys are really great. But did you think how you're gonna make it like a real product and sell it in the market? Do you think are you thinking in the next step?
Yes, of course. We test it a few times.
Great. Do you want to make any modification to release it in the market in the future?
Why not? We sure this product can be covered.
Perfect. I'm sure. Great. Thank you.
Thank you. And next, Mr. Kastik, please.
So did you do this all by yourselves or did someone help you with this project? Could you hear me?
Yes. Anyone help with you or you do it by yourself?
It's all right to take help. Just would like to know how you went about making this.
Yes.
I help by our teacher.
Yes. Great to know that. Thank you. Thank you. So let's take 1 minute for the judges to take on everything on their rating sheet. So the third group, be ready. Thank you all.
Thank you. Thank you.
Okay, so let's welcome our third group, the prototype of device that recognizes car crashes and risks for hydroplaning. Let's welcome. Do you have any slide to share?
I do. Could you also spotlight my friend?
Yes, where is she?
I'm here.
Okay, you are here. So Tasha's here. So we still have to find Elizabeth, right?
Ella.
Ella, okay. That's going to find, yeah, here we are. Yes.
Okay.
Whenever you're ready, yes.
Good afternoon, judges, participants, and everyone. Hello, I'm Tasha.
And I'm Ella, and our project is a prototype of a device that can recognize car crashes and risk of hydroplaning.
Okay, identifying and understanding. So road accidents are particularly dangerous in Indonesia because roads are not fully developed in many regions. According to this table from 2005, there is a high correlation between fatality rates from crashes coming from rural areas. Accidents often go unnoticed in isolated places because nobody is around to witness them at the time. And this delayed medical attention will increase the likelihood of injuries becoming more fatal. And also, also, Indonesia's urban areas have many toll roads that during rainy season can cause hydroplaning. This doesn't only risk the life of the driver, but also others around them because the driver loses control of the vehicle.
So when we were finding the idea for this project, at first we wanted to use the push button as a send help function. And we also at first wanted to use a phone application instead of a physical device. However, we decided to create a physical prototype as well as link the device to not the driver, but to an emergency contact. And this is because car crashes are very sudden and often lead the driver to be knocked unconscious. A physical device that would be integrated in a car would be also more accurate because there are less factors that are affecting the acceleration. Finally, we wanted to make sure the emergency contacts are notified in case their family member or friend is in a crash.
So designing and building the solution. First, we drew a schematic diagram of the device using fritzing. In the center, there's a Node MCU microcontroller that connects to the water level sensor, the GPS module, a push button, an accelerometer, and an LCD monitor for inputting and outputting information. We also designed a flowchart to outline how the device will work. So initially, all safe is displayed on the LCD. Then it checks if extreme deceleration, like if a crash has happened. If not, then it checks if flipping has happened. If not, it checks if hydroplaning or submersion has happened. And if not, it still displays all safe. But if yes, if any of those three scenarios happen, then a 10-second timer will start. And if the driver pushes the button indicating a false alarm, all safe will still be displayed. But if not, then a location will be sent to the app and to the emergency service. Sorry. And this is part of designing our device. So we also wrote the code so our Arduino can connect to the app through MQTT. When data is collected by the sensors, it is published to the server on a topic like latitude or longitude. Then the app subscribes to that topic to receive the data and present it to the users.
We also used roll and pitch as well as the individual X, Y, and Z values from the accelerometer to calculate if a car has flipped or gone through extreme deceleration. Here's a class that we created whose methods represent the current position of the car with an object we call current. And for the accelerometer, we actually had to calibrate that first, and we used it through experimental values that we got ourselves, and that's by finding the offsets. We also divided everything by 256 because that's how we get it to be all in terms of G. For hydroplaning, it's a bit more difficult because we can't actually use a car, so we just use data and numbers and formulas that we got through research on the internet. Here are a couple of the process pictures we did. We implemented the functionality one by one so that it'll be easier to debug.
Okay, testing and refining. To protect the components and wires from being damaged in a crash, we created a 3D casing using FreeCAD. It is designed in a way that allows drivers to see the LCD and easily access the button when they need to. And then to test the actual device, we positioned it on a sled and observed its response to different scenarios. So here is when it's submerged, when it's flipped, when it's crashed, and when it's all safe, then all safe is displayed.
So in total, it costs about $27, which is a bit more on a pricier side, but actually we can cut the cost by a lot because if we're going to actually make this, we would like to integrate it into the car. And the car, of course, already has the GPS and the accelerometer, and so we wouldn't have to buy that instead. Also, we did try and optimize this, which is why we bought a couple water sensors and a couple extra GPSs, and also found different ways to accomplish the same goals, such as using a breadboard instead of just connecting everything directly. And this is, again, just to make it a little easier for us to debug and keep all the code and everything organized. That's it. Thank you.
Thank you. Lovely pitch. And I would like to welcome our judges to give up questions. And first one, Ms. Kalud, please.
Yeah, I just had in my mind that the really modern, expensive cars, they already got this maybe feature, but for like a normal people who drive normal cars, they don't have that option. But for $25, you said we can buy this device and protect ourselves. It's really amazing. I really like the idea, and it's really great. So my question is, so have you thought about really producing this device and take it, put it in a real car and test it in your maybe parents' car?
Maybe because the way we thought of it is to actually have it inside the car. So when it's produced in a car, it would already come with it. And that way we can just use the GPS that the car has instead of having to have double of everything. That would require a bit more, but yeah.
Okay, great. Thank you.
Thank you. And next one, Mr. Wu.
Hi. Very nice invention, and it's very helpful for a lot of cars without any accident report. And I just wonder, how did you sign off this a single GPS location and so on? Is by wireless network or by wireless network, right?
Yeah, we decided to make the casing because in the beginning, we had a lot of sensors, and so everything was sort of like a mess, and we wanted to keep it all in one container so that it's easy, so it's portable and we can bring it around easier, but also because we have a water sensor, and so if the wires get wet or if water touches the other sensors, we're afraid that it would damage the quality of the sensors too.
Okay.
Okay, thank you. And next one, Mr. Kathy.
So what is the biggest challenge you faced in this project?
Do you want to do it?
Yeah, you could.
I think it's because we've never done like an IoT project before, so we had to learn everything from the beginning. At least that was, I think, the hardest part for me.
Yeah, there was a lot of resources that were introduced to us in the beginning, and it took a while.
Thank you, great. So any other questions from our other participants? If you have any other questions, you can just leave it in the chat box and I will read it to our participants, okay? So let's leave our judges 1 minute to fill out their judging sheet. Thank you. Thank you, E1C. And now, Team E1D, get ready. Okay, so Team E1D, water hyacinth wallpaper as thermal insulator. Okay, let's welcome.
Okay, so I will share our presentations now. Could you see our presentation?
Yes.
Okay. Good afternoon. For our innovations to be presented today is Water Hyacinth Wallpaper as Thermal Insulator by Pichaya Kanchanabat and Suwapit Thongpunchum from Princess Chirapon Science High School, Pathum Thani, Thailand.
According to our studies, the insulation that we currently in use causes many problems, including being biodegradable and is also being unhealthy because lung disease and has difficulty during installation. Therefore, we observe and state the condition that our insulation should have in order to solve the content, to solve the problem that we just mentioned. And after that, we create the test piece and also the experiment.
To create our test piece, we started by preparing our water hyacinth fibers and natural laboratories. Then we form the wallpapers by break it in the hot air oven.
For the first condition, it should be easy to install, so we decided as a wallpaper which has 2 layers, consisting of double-sided adhesive layer, heat insulation layer, and printed film layer.
The second condition is it should be made from biomaterials that have insulating properties. So we decided to use non-water hyacinth that is a weed that causes many problems in Thailand. On the other hand, it also has heat insulating properties because of its porosity structure. The third condition is it must be flexible and lightweight because we have to put it on the wall. So we use natural latex to form the wallpapers because it is flexible, lightweight, and has low density. Moreover, it's produced from rubber trees, which is widely cultivated in Thailand. In these experiments, we study water hyacinth fiber ratios for optimal insulating and tensile strength properties. We use the control group with our water hyacinth fibers and 5 experimental groups with different ratios of water hyacinth fibers.
For the fourth condition, our work should be able to withstand fire. So using the best fiber ratio obtained from the first experiment, we add borax into the latex. And for our experiments, we studied the different doses of borax on the flame retardation property. So the control group will not have borax, but we have a different doses of borax and 3 experimental groups.
The fifth condition is it must have antifungal properties. So we add nano zinc oxide, which has the ability to inhibit the growth of fungi on our wallpapers. And we use the best ratios of water hyacinth and the dose of borax on the wallpapers from the obtained through the second experiments. In these experiments, we study different dose of nano zinc oxide to the ability to prevent fungi growth with control groups without nano zinc oxide and the experimental groups with the different doses of nano zinc oxide.
And the last condition is our work should be low cost. For it, production would be worthwhile and be able to use as a long-term replacement for the insulation on the market. In conclusion, the test piece containing 70 grams of water hyacinth fiber and 15 grams of borax provides a base property as it had a heat conductivity of 0.141 per Kelvin, which is equivalent to other insulation as we research, and also has the same size strength of 40.6 megapascal of the Thai industrial standard, as well as having a ability of fire retardance and preventing the mold growth. So the water hyacinth as a weed can be benefit from this work. The wallpaper characteristic is shown in this slide. Thank you for your time and consideration. You are welcome to ask any questions you may have.
Thank you. Lovely presentation. And now let's welcome our dear judges. Mr. Karthik, yes, please.
So does something like this already exist in the market? If not, why do you think it's not yet been done? And if yes, how is your product better?
The thing like for insulators, wallpapers has appeared in the market, but it's made from foam, and foam is not environmentally friendly. And the reason why that is not have the wallpapers insulator that made from water hyacinth wallpapers of biomass, because when we talk about when we reform the biomass into the insulators, they also use it to make it in a insulator form like a block, and it's not in the wallpaper shapes. But I think the reason that they don't do it like our innovations because they consider it just about the insulator's properties of their insulations, but they didn't consider about how easy for user to use.
Yes, so that we can say that our work is special if we look at how easy we can install this insulation on the wall as we decide as a wallpaper shape.
Yes, small wall is finalist for our innovations.
Yes, thank you. Appreciate. Okay, next, Miss Khalud.
Yes, just to remind me, how was the cost for this wallpaper?
The cost that we use for our innovations and we use for our experiments is $268. However, we call the experiments cost too, but when we consider that our wallpaper hyacinth fibers is lower than the foam wallpaper that have in the market because it's made from the wheat like water hyacinth, and the rubber latex can easy to find in our country.
Great, thank you.
Thank you. And then Mr. Wu.
Hi, it's very beautiful wallpaper, and I think this environment is good to environment. I just wonder, did you contact any factory to produce your invention?
We didn't contact any factory yet because it is work we like creating the prototype and developing as we giving it the condition that we think is useful to make an installation. So this is like a prototype, and we are looking forward to developing it, improve the features. And about contacting the factory is something we would like to look forward to, and that's really an interesting idea. Thank you.
Yes.
Okay, thanks.
Okay, thank you. Thank you, Group 1D. Now let's take just 1 minute for the judges to taking down on their rating sheet. Okay. Okay, Group 1E, get ready. So black soldier fly compost. Group 1E, are you here?
Yes.
Yes, great. Okay, are you going to share your slides?
Yes. Sure.
Great.
Okay. Hello everyone. We are from Baitur Rahman Islamic Boarding School Indonesia. My name is Amara. I am Fatia. And I'm Nurfada Aziza. And here we are presenting our project, which is based on STEM project, which is black soldier fly compost. Okay, so first, what is the problem? Since we live in a boarding school, we have so much organic waste from the food waste every day that they're just being thrown away directly. And this will cause the waste to release more methane to the atmosphere. And also, in our boarding school, we have decorative plant nursery, but we still use chemical fertilizer, which is not too good for the soil. And this challenge is related to SDG number 12, which is responsible consumption and productions, and also SDG number 13, which is global warming. The possible solution is using the SF composting method because it's low in cost, profitable, easy to do, and innovative.
There are 5 steps that we have to go through in the solution invention process, which are research, imagine, design, create, and testing and evaluation.
In research step, we identify what kind of decorative plants that are available in our school and finding out on the internet what are fertilizers that used for decorative plant for additive to the BSF compost.
In the imaging step, we compared 4 kinds of decorative plants, which are aglonema, bougainville, miana, and lily. Based on their advantages and disadvantages, the chosen plant is miana. We did some things to the fertilizer. The fertilizer we compared is Gandasilbe.
Based on the imaging process, the final and chosen combination were miana and Gandasilbe, and these were the tools and the materials we plan to use on the next step, which is creating the compost and the fertilizer mix. And the third step, we implement the design that were decided in the previous step.
And for the last step is experiment. We test the compost and fertilizer mix on miana for 14 days, and after that, comparing the miana with the mix with the control plant. And the results shown, miana with the mix has a better growth and a brighter color compared with the control plant. And the last is testing and evaluation. And here we have RNC, which is 3.8 point that show how valuable these projects are. And the profit for the first harvest will be 44,700 rupiah. And for the rest of the harvest will be 81,200 rupiah.
So is this a realistic solution?
The BSF compost and Gandasilbe fertilizer mix can be a realistic solution for organic waste management and reducing the use of chemical fertilizer because
it's easy to do,
low cost as you can get the organic waste easily and for free.
Better for the soil,
still increases the growth and the color of miana.
Thank you for your attention.
Thank you. Thank you for your lovely pitch. Now let's welcome our judges. So Mr. Wu first.
Yes. How long did you take to test your fertilizer? The whole semester or how long?
So for the first testing, we have 14 days. So it just tests that the BSF compost is successful and we can see the bigger growth. And for the picture in our presentation, it took 2 months to 3 months. So it showed the difference between the miana with the mix and miana control, where miana with the mix has a brighter color.
Okay. Thanks.
Lovely. Thank you. And then Miss Clue.
Okay, so have you asked some of your family or friends to try this, except you? Have you tested in the community?
Yes,
Yeah.
so in our school, we have an extracurricular, which is decorative plant nursery, and we already test this product, which is the BSF compost, and we take this product to that extracurricular, and the kids in our school already tried this.
Perfect, great, thank you.
Yes, thank you. Then Mr. Karthik, please.
How will you take this idea to more people outside your school?
Yes, so this product, we can sell this, and also in our school we have here in our school we have plant seller, so we can sell this compost to our local seller and also the kids in our school and also our parents. And this miana is a popular plant, so it has this value, so we can sell the miana.
Great, thank you. So judges are taking 1 minute to write on their rating sheet, and group 1F, get ready.
May I share my screen, please?
Yes.
Thank you. May I start?
Yes, you can start now.
Alright, good morning, everyone. Today I'd like to give a pitch about my automatic plant watering system. First, let's look at some numbers first. 47.5% of the US states are in droughts in 2021, and 50 million people are affected by droughts every year. And 2/3 of the world experience severe water shortage for at least 1 month each year. So in 2021, the government of Vietnam declared that it was a year with historical droughts. And so I would like to introduce my invention of a machine that will water the plants and also detect and predict droughts. First, there are two separate parts to this. First is the physical part where it will actually water the plants and use just the correct amount of water, rather than just farmers randomly watering whatever amount of water they feel like. This system uses a moisture sensor, a water depth sensor to measure the water reservoir to see if it is filled or not filled. And then all of that is communicated to the relay, which then opens the pump or close it. The results of the moisture sensor data is directly shown on a website that is hosted by the microcontroller in the middle, and then the data can also be accessed by a different AI, which then use it to predict with previous data that it has collected about the depth of water, weather forecast in the future, to see that if it matches any previous drought condition, so that actions can be taken beforehand. On your right is a picture of the prototype that I've built. Currently, the temperature moisture is minus 18% because, as you can see, the sensor has been pulled out of the soil. So how does the website works? First, the microcontroller, so the machine in the middle, it will send the data to a website, and the website collects all the data and plots it on a web. So how did I put all of this together? First, you have to buy all the components and test and verify that each one of them works properly, and then I just connected all the components together and then programmed all of the connected components. The language I used was C and HTML as well as JavaScript to program the actual thing that farmers actually use, and for the AI I used Python. The total cost of the machine is about $40, which seems a lot, but the shipping costs need to be taken into consideration as well. Shipping to Vietnam is pretty expensive for some reason, and so I think that a third of the cost here is for shipping, and I think if we scale it up, the price of the machine can reduce significantly. This will solve SDG 13 and 15 because droughts are the consequences of climate change, but this machine will help the soil, which solves this SDG 15, and it will save labor cost since you don't need to hire people to go around and water your farm. I will now yield the rest of my time and take questions. Thank you.
Thank you. Thank you for your pitch. Let's welcome our judge, Mr. Karthik, to give you your first question.
So what are the challenges that you faced as you made this?
Some challenges that I faced was, for example, when I've already tested all of the components, it works, but then when you connect it all together, there are some errors, and it's just a matter of testing and fixing stuff. And another is the weather conditions. Vietnam has a lot of moist, so the humidity is very high, so you have to put a machine in a box so that the moisture will not affect the machine, and it needs to be weatherproof as well.
Thank you. Then let's welcome Ms. Clute.
Thank you. My question is, the components that you have used, how did you decide this is the right one to use here, like relays, and have you used the Arduino as well? How did
Yes.
you decide those are the right components for your idea?
Yeah. So the board that I showed is just an Arduino with a Wi-Fi chip tagged on it. It is an ESP8266. Um, so I just chose what I needed. So for example, I needed Wi-Fi, but I didn't need Bluetooth yet. So I just chose the 8266 other than the 32. And for the moisture sensors, first I used a bronze sensor, but then after like a month of using it, the bronze just teared out, and then it didn't work. So I used a capacitive sensor, which has longer longevity. And the relays, first I used one that was directly on the board, but then the risk of failure was high, so it is really hard to replace one that is on the board. I just extracted it out on another component.
Brilliant, thank you.
Thank you for your
Thank you.
question.
Then Mr. Wu.
Hi, thank you for the presentation. You talk about the cost. Did you have plan to reduce the cost for the $40? Is still very high.
Yes. So as I stated in the presentation, lots of the shipping, like a third or a third, maybe more than that, a little bit, is for shipping. So when you scale it up, I think the shipping cost will play a smaller part in the whole scheme of things, and the machine can reduce its cost significantly.
Okay.
Thank you.
Okay, thank you. Now it's 1 minute for our judges to note down their rating sheet. Thank you. So our next group is 1G, employ. Get ready for that. Are you going to share the slides? 1G, group 1G, yes?
Yes.
Yes.
Can I be heard?
Yes, you can start now.
Okay. Hi, I'm Natalia.
And I'm Annabelle, and we are here to present our innovation, Employ.
My dad works in the agriculture business in Indonesia and once discussed with me the difficulty in the process of finding temporary staff despite both high demand and high supply. Based on a survey conducted by the Ministry of Manpower, about 88% of companies have suffered a decrease in sales, leading to sizable financial losses since the attack of COVID-19. This burden could be minimized by reducing the number of permanent staff and replacing them with temporary employees. This is because companies would no longer need to pay monthly salaries and benefits, leading to them becoming more cost efficient, among other advantages. According to Statistics Indonesia, 24 million people work shorter hours, 1.7 million people were furloughed, and 2.56 million people lost their jobs by November 2020. These are the people in desperate need for jobs to improve their financial situation. The problem is the big companies like those in the palm oil industry have trouble efficiently finding temporary laborers, and job-seeking workers have trouble being found. The market who is looking for a solution for this problem is rapidly growing, especially during a pandemic and a time of economic uncertainty.
During our innovation process, we decided to design a website instead of an app in order to accommodate those without mobile phones and will access it through internet cafes known as Warnet. We brainstormed key features needed for a solution to the problem and discussed a general flow of the website that the user would experience. Our competitive advantage is that none of the current existing platforms such as Gojek, LinkedIn, or Upwork focus on the primary sector like we do. The primary sector is the strength of Indonesia, as it has high rates of uneducation and has unemployed workers who are looking for unskilled manual work for wages. After ideating, we created a prototype for our innovation using an online platform called Figma. In order to make our prototype functional, we used Figma's prototyping tool to make the elements of our website interactive. We then tested our website many times in order to make sure that the buttons are functional and to give others a clear idea of what the finished website would look like.
Finally, we can proudly introduce our solution, Employ. It is an online marketplace that connects employers and employees for manual labor jobs and jobs in the primary sector. We made it as user-friendly and accessible as possible so that users can operate it easily. Our platform enables employers to post temporary jobs that do not require much skill, such as harvesting crops and operating machinery. Employees will then be able to apply for these jobs to earn wages. Our target employees are lower-class workers, and our target employers are any businesses who need help with general labor. Employ has multiple functions, which we will demonstrate with our prototype. So this is our home screen. When the user registers as an employee, this will be their employee home screen. Employ enables job-seeking workers to search and apply for the temporary jobs. Employ also aids the employees in managing their ongoing jobs and their completed jobs. As an employer, this will be our employer home screen. Employ enables employers to post temporary jobs and recruit temporary workers. It also aids employers in managing their ongoing jobs and their posted jobs. It also allows for direct and instantaneous messaging between the employers and the employees. Moreover, it allows for a two-way review between the employers and employees. Last but not least, it oversees monetary transactions and conducts them immediately after a job is completed.
Our solution aims to aid both the employer and the employees involved in the problem and reduce unemployment in Indonesian society, effectively working towards the United Nations' first Sustainable Development Goal, no poverty. We believe that our innovation has great potential. In creating a platform that easily connects employers and lower-class employees, this solution could be expanded to cover other sectors such as maintenance work that includes housekeeping, repair, and more. And that is it for our presentation. Thank you.
Thank you. Now, let me invite our lovely judges, Mr. Wu, to give you questions.
I just wonder, did you have any recommendation algorithm to connect the employer and the employee? Did you design such a recommendation algorithm in your webpage or your project?
For the recommendation function, we have not created our prototype. Has all the basic functionalities, but it is still unable to do the recommendation function, and even the posting are accepting actual real-life jobs. So our next step would be to design a functioning app based on our prototype. And we think that this will have a great impact and improve the economic well-being of millions of lives, because it will allow unemployed workers to get quick jobs with low skill requirements and thus drastically improve their financial situation. So
that is good.
Okay.
Thank you.
Yes, thank you. Now let's welcome Mr. Karthik to give you questions.
So let's say that a website that's probably operating in another country, but with the same segment enters and offers the same, features that you're offering. What will you do?
So actually, we did our research on all the different existing prototypes, existing websites like platforms such as Gojek or LinkedIn and Figma. Fiverr. And we realized that our competitive advantage is that none of them actually focus on lower class workers and jobs like manual labor jobs, which is more on the important side of Indonesia.
Yes, thank you. And then Ms. Khulud.
Yep. So that's great idea. I love it. Did you think how you are going to market it? What kind of platforms you are going to use, and how you're gonna let people know that you've got this option here? Come and try it.
We did discuss about like the costs and what our costs would be for this solution. And since
our project requires a web developer, and we will pay them around 2 million rupiah per month. And according to our research, we can also do sufficient maintenance without much more cost. And we realized that other costs like advertising, which we will do in platforms such as Instagram or like relevant platforms such as like Facebook, who are for more like older people. And we realized that all these costs can also be covered with our income, which is gained as a small percentage of each of the monetary transactions between the employer and the employee.
Perfect. Thank you.
Lovely. Thank you. So now let's take 1 minute for our judges to write on their rating sheet. Group 1H, carbon dioxide capture system. Get ready. Do you have to share your slide?
Yeah.
Yes, yes, please.
Are the judges ready?
Yes, I think so. I think you can start.
All right. Greetings, respected judges and honorable adjudicators. My name is Atsara Israpanich from International School, Bangkok, Thailand. Today, I'm going to propose to you the project that I developed called Carbon Dioxide Capture System for Modern Greenhouse Cultivation. Let's look at the problem that currently exists in our society. From the graph here and the image here, you can see that temperature is rising globally every year and carbon dioxide concentration is increasing every year. However, plants are a sustainable alternative solution. Looking at the photosynthesis equation, plants require carbon dioxide as the reactant and thus to grow. So these are the current devices that are out in the market to assist plant growth. However, the high cost and massive size of them makes it inconvenient for farmers and especially Thai farmers. So now I'm going to talk about the process. So on to the first step, selecting the CO2 capture method. There are a total of 3 main methods. But for methods 2 and 3, the separation with membranes and distillation of liquefied gas stream and refrigerated separation requires a high price and also a large area, and the advanced technology makes it inconvenient. Methods 1 had a lower price and was more convenient considering the application for the agriculture setting. And then there were 3 types of chemical that I had to experiment with. So here in the graph, I've performed an experiment to see which chemical was the most efficient. The results I collected indicated that triethanolamine had the highest performance, and additionally, the price was lower and it's very accessible in Thailand. Now to the design aspect. So this is the overview of my total project. The full system is split to 3 separate parts: the CO2 capture system, sun parabola, and the greenhouse. Going on to the first feature, the CO2 capture system. On the right here is the 3D CAD model, and this is the actual product. So next is a demonstration that I will show you. So first turn on a machine to compress the air inside, pour the TAA into the tank, then allow the machine to do the chemical mixing. Turn on the pump to help circulate. So this is the data collection, and open the cap at the bottom for the machine to allow the chemical to flow into the tank. So after the liquid is stored into the tank, it will have to go through the heating process. So the sun parabola system will heat it at 60 to 80 degrees Celsius, and in order for the chemical to release the pure carbon dioxide absorbed. Then there will be an automatic fan powered by the solar panel, as you can see here, that blows the CO2 through the funnel into the greenhouse. And inside the greenhouse, there's a CO2 sensor that measures the concentration of carbon dioxide inside. So when the concentration of CO2 that was set is exceeded, the fan will stop blowing and it will perform this cycle during the afternoon period. So this is basically the product application. There are 3 basic systems, basic words to it: capture, heat, use. So now moving on to the test results, I've conducted an experiment to see the carbon dioxide in the chamber. So the graph orange line shows the amount of carbon dioxide when I tested in an environment with 226.1 ppm of carbon dioxide. The CO2 can be greater or lower depending on in the environment you're in. And the graph below, the blue line graphs indicate the carbon dioxide released. The TEA can release a maximum of 2,000 ppm of carbon dioxide per liter at 30 minutes or at 66.45 ppm per minute. In other words, the TEA saturates at 2,000 ppm. So this is my experience to test the product application in this mini greenhouse. I've planted the morning glory seeds since it grew quite fast, and the results demonstrate that the morning glory, when using a CO2 system, presents a significant growth of 21.5 centimeters, higher than a morning glory without using a CO2 system of 12 centimeters. So now onto the impact aspect. As for the environment, this will help decrease the CO2 and allow us to work towards UN Sustainability Goal, especially number 13, climate action. In the society, this will help promote the use of green energy as the sun parabola system suggests and help raise awareness of the sustainability goals overall. Not only that, it will also extend to assist in the economic prosperity due to the increase of crop yields that the system provides. And apart from this, I've reached out to farmers in Thailand and many were interested and they have helped out to test the product and provided suggestions and comments to upscale it even more. I'd like to also highlight that I've pitched at the Youth Startup Fund in Thailand, which was provided the fund to create the commercial prototype to be launched in the market by the end of this year. User-friendly, high productivity, and low-cost carbon dioxide capture system for modern greenhouse cultivation. Thank you.
Thank you. That's impressive. Now let's welcome our dear judges to give you questions. So first, Ms. Khalud, please.
Wow, I just have to say that's amazing. I have a question. How long did it take you to, when you got the idea and you just tested, you build it, I don't know how long it took.
So like, it actually began from my interest in like promoting for climate change and doing like extracurricular and service in promoting climate change. And at school, I've always been entrenched to, sustainability, climate change. And from reading many literature reviews from like previous years, I have came to realize that I want to create change and like I have an aspiration to create this innovation and do many literature reviews. I've came to see the other products out there in the market first. So like the one I've shown here, this is the DAC technology, the direct air capture that has also already been developed. So I took that idea and see where I can innovate it and make it applicable in the agriculture setting in Thailand and also around the world as well.
Perfect, great. Thank you so much.
Thank you.
Thank you. Now let's welcome Mr. Wu to give you questions.
Hi, I think this is a great idea. And I just wonder how, did you compare the cost and the gain with your project?
Oh yeah, I actually have a slide on that. I'll show you right now. This is my business model canvas. So this is the cost that I compared. So the cost to build my system, including the CO2 system and the parabola, is $275 US. The market price that I'm setting is around $1,000. However, and when compared with the Climeworks, the DAC technology, that is placed at $10 million, like over $10 million for the whole system. And furthermore, I've also done a preliminary market investigation and found that we have many interested customers of more than 1,200 greenhouses as well. Yeah, I'll go on, since we're already on the price, I'll elaborate more on the return of investment as well. So like the return of investment ROI is about 6 months for growing green oak and red oak in 6 times 30 greenhouse that I've done an investigation on.
Okay, thank you.
Thank you. Now let's welcome Mr. Karthik to give you questions.
So let's say that you are able to take it to thousands of greenhouses. What is the impact it will have on society?
So first one, if we look in the economic aspect, more crop yields, more farmers are able to grow crops faster, as shown here in the Morning Glory, also my other experiments. Secondly, the society will benefit from using green energy, using solar energy, sustainability as well, since our system uses only green energy. And also the TA, the chemical, is environment friendly as well. It's reusable over 10 times. And lastly, for the sustainability, what else? Sustainability development goals. Yeah, so those are the goals that I've shown you already. Yeah.
Thank you.
Thank you. And now let's give our judges 1 minute to write on their rating sheet. And group 1J, get ready. Okay, so now let's welcome group 1J. Do you have any slides to share?
Yes.
Yeah, you can share it now.
Okay.
Okay, Drax tofu meatball. Are you ready?
Yes.
Yeah, you can start now.
Good afternoon, Judge. Let's introduce our team. My name is Muhammad Faiz Fatah Sajidullah.
I'm Muhammad Zafran Kanadani.
And I'm Muhammad Rafi Walidin. We are from Baitur Rahman Senior High School, Bandung, Indonesia. Now we would like to explain about our STEM project, which is Drake's Tofu Meatball. In our area, there's many factories produce tofu drakes, which is low in price. In addition, 1 kilogram soybean will produce 2 kilo tofu and 1.1 kilogram drakes tofu, which means the tofu production produce very high solid waste. This gives us challenge to increase economic value of drakes tofu. To find best solution, we use 3 criteria, which are economic value, poverty and demand, and health. In the inventing process, we divide it into 5 steps, which are research, imagine, design, create, test, and evaluate.
In this step, we search information about possible products that can be made from Drake's tofu as shown in this picture. Based on information collected and criteria, we decided to choose culinary product. From the information collected based on many aspects related to culinary product and criteria, we come up with several ideas, which are dim sum, meatball, and dorayaki, based on criteria which are economic value, popularity and demand, and health. We compare this culinary product and decide meatball as the best choice, as shown in the table. For this product, we use Drake's tofu to reduce red meat and produce Drake's tofu meatball. The picture shows the recipe and its ingredient where Drake's tofu used as substitute of red meat. Half kilogram Drake's tofu mixed with 1 kilogram red meat, so the composition is 1:2:2.
This one is production process of Drake's tofu meatball as shown in the pictures. In this step, we do SORPA test as shown in the pictures. First, economic value by doing RZ analysis and cost reduction. It gives 2.29 for RC, which means that the product is feasible to sell and gain 31% of cost reduction. Second, ergonomic test, which consists of 4 aspects and result in average 3.5 out of 5 scale, which means the product is accepted by tester. The Drake's tofu meatball is a realistic solution based on 1. Economic value shown by its RC score and cost reduction and profit. For one recipe, it costs $20.3 for 100, which is usually sale price is $0.35, so net profit is $13.8, which is 68%. 2. Organoleptic test, which accepted by tester, and meatball is a popular food and high in demand, and so possible for Drake's tofu meatball. 3. Drake's tofu reduce ammonia on red meat, so it's good for red meat diet. 4. Drake's tofu meatball can be made as Drake's tofu ball, which is suitable for veggie. 5. It also supports CDGs number 12 regarding responsible consumption and production, which heavily reduce carbon footprint. Thank you and have a good day. Alhamdulillah.
Oh, everyone's hungry. Thank you. Thank you for your lovely pitch. So now let's welcome Mr. Kusik to give you first question.
So how did you come up with this specific idea of, looking at the Drex tofu? Why this? And
Can you translate that?
Say it again, topic. I'm trying to help with the translation for them.
would you like me to repeat or?
Please.
Repeat it.
Okay. So did you have how did you know that about Drex tofu? How did you learn about Drex tofu and that it is there produced in so much quantity? So just that, how did you learn about it? Where did you learn about it from?
Because we do some research and we find some reference to create this. And in our area, there's a many factories tofu Drex. And it gives us challenge to increase economic value of Drex tofu itself. And find best solution, we see on the reference. We choose 3 criteria, which are economic value, poverty and demand, and health.
Thank you. Lovely. And then Mr. Wu. Yes, please.
Hi. Sometimes the healthy food cannot be good taste. How many people help you to evaluate the taste of your Drex tofu or meatball?
We already sold it in 5 expo, which last expo attended by community, teachers, and our district and major himself. Every time always sold out. We don't know how much the number.
Okay.
Yes, thank you. And then Ms. Clued.
Hi, I've never tried tofu. I'm really keen to try this. But my question, what improvements would you like to make in the future to make this like real product?
Drex tofu without meat, like Drex tofu ball.
Yes, thank you.
Thank you.
And now let's give our judges 1 minute to write down their rating sheet. I know you are hungry now. You can get something to eat now, I think. Team 1K, get ready.
Okay, wait a minute.
Yes, you can share your slide now.
Okay, can you see my screen?
Yes.
Okay. Good afternoon, everyone. Today, I'm going to present our innovation, which is pectin extraction from permanent fuel through the sodium arginate with verification for hepatitis patients. First of all, let me introduce myself first. My name is Himadazi Tilawong.
My name is Anshma Musamba.
And our advisor's name is Ms. Thon Han Chowong and Ms. Farida Tang Angrat. So, according to the World Health Organization, hypertension is the leading cause of death for worldwide up to 7.5 million people, or 12.8% of all death. Food and medicine that has sodium content tend to have a salty taste. And the more salt you eat, the more it promotes an increase in blood pressure. And you know what? Sodium arginate is one of the most popular water-sorbent hydrogels. When mixing food, it will make it thick and rich cell. Therefore, it was used in many food and medical medical applications. That's why we look for something that can be used with sodium arginate to reduce sodium consumption. And that is our pectin, which is extracted from palmetto peel. That is a soluble fiber that's important to control blood sugar levels, reduce cortisol levels, and also maintain the digestive and digestive system. That is very important to help people with high blood pressure. By using orange juice at the preliminary study to replace food and medicine that usually contain of sodium. For our objectives, the first one is to study the properties of pectin that we are extracted, and then to produce orange juice bait by certification. And the last thing is to study the efficacy of orange juice bait. So what we are going to do, we have divided into 3 experiments, and the first one is to compare the properties of pectin and then examine the appearance of orange juice bait by using stereo microscope. And the last one is to look for the efficacy of orange juice base. And here is our summary of our experiment as a 2D prototype that we are planned for our experiment.
And here is our result. For the properties of pectin, we found out that the amount of pectin extracted was higher than pectin extracted from the other plants, and they were classified as HMP pectin. This was feasible to be used as an equivalent to commercial pectin. And for the appearance of orange juice bait, we found out that the first formula has close set to the control set, and the fourth formula had the most vivid color and different appearance to the control set. That's because a decrease in sodium arginate concentration results in less spherical shape retention. And for the efficacy of orange juice bait, we found out that the first formula has the weight, the diameter, and the thickness of gel film closer to the control set. From figure 1, the weight of orange juice bait tended to increase with the increase in the pectin ratio. From figure 2, as a result of more gel conservation result in more gel constriction, which contradict the experimental result. From figure 3, when the concentration of calcium and arginate increased, the film thickness was increased as the film thickness intended to be decreased when the pectin content was too high. And for the table below, the base from the first formula has the most vivid color and brightest. Thank you for your attention.
Thank you. And then let's welcome Ms. Clude to give you questions.
Yeah, how did you get all this information? Is there anyone helped you? Because it sounds like advanced chemical thing. Did you have any advice from teachers, from parents?
Yeah, also we have our advisors in here, which is Ms. Pan Han Chong and Ms. Datang Anurat. And there is our teacher at school to help give a suggestion about the method, about the experiment, and also the teacher Palida Datang Anurat who gave me an advice too.
Perfect, great teachers, great help. Thank you.
Thank you. Now let's welcome Mr. Karthik to give you questions.
So what is the main challenge that you faced when you were going through this process?
Okay, the main challenge is the step of the extraction that we extracted pectin from the palmetto peel, right? So every step, like every barrel, every quantity is very important. For example, when we extracted the pectin from the palmetto, if the palmetto powder that is not powder, like they have not the stable size, then our pectin solution will not participate. Yeah, and furthermore, you know what, this is our third times of extraction because it's very hard, or even like the oven that we heated the pectin to dry it, if it's too hot, then it can get burned very easily. So that's the main problem that we are facing.
And in the sulfurification method that we use, if we mix a ratio between sodium arsenate and pectin, if we mix it is not stable, it will affect to a spherical shape of orange juice beet too.
Yes.
Thank you.
Thank you. Now let's welcome Mr. Wu to give you questions.
Yeah, I'm not a chemistry, so it's very complex for me. I just wonder, how did you get help to analyze those chemical components? How did you get help? Chemical components such as how much this, how much that?
Yeah, of course, the most chemical component that is very important is sodium arsenate, that we find the amount of it by taste it at ourselves. Like we need to find the control set, right? We need to add a little bit more of sodium arsenate until we can make our spherical shape it is stable. That we need to add a little bit more, a little bit to our spherical shape, like our orange juice beet, as we are using like the minimum of sodium arsenate, because we need to lower our sodium as much as possible.
Okay.
And also we research it.
Okay, thank you.
Yes, thank you.
Okay, thank you, 1K. So now let's give our judges 1 minute to write on their rating sheet. Last but not the least, team 1L, geothermal monitoring application.
Let me share my screen first. Yeah, okay. Good afternoon. Today I'm going to talk about Geosol, which is basically a geothermal monitoring application using light distance ranging technology. So Geosol is basically a geothermal monitoring application using light distance ranging technology, or LiDAR, that mount on drones. Just as radar uses radio waves and sonar uses sound waves, this technology uses light waves from a laser to detect objects. The system calculates the total time it takes for light to find the target object and reflect the scanner. Once this happens, the system calculates the total distance, which with the help of the speed of light, and this process is also called the time of flight measurement. The system is powerful enough to quickly and stable fire 500,000 pulses every second, and the pulses are then collected to a cloud or coordinate database. And the point of cloud can then be used to create meshes and 3D models to help create effective point to help create 3D models of the geothermal energy before it goes through the software. And from this, it will be outputted towards the device or the Geosol application. So this is a basic flowchart about how Geosol works. We first basically have a mount sensor to the drone camera, and when it synchronizes to the app, the drone will fly to its designated direction and will take the picture, and the output will give out the temperature values, the detected regional coordinates, and air pollution levels. So we provide government and civilian scientists a way to collect better quality of data in an environmentally friendly way compared to satellites. The process of getting data from satellites takes a lot more time, is much more expensive, and the quality of data differs vastly. So using Geosol, we will be able to get better quality data as well as much more bigger data in a much more lower cost and in a much more environmentally friendly way, since all we use is light distance ranging technology. And our target, and basically Geosol is a B2G as well as a B2B business model. So what we do is that we basically advertise this to many government agencies, and we hope that in the future policies will change where government agencies recommend Geosol towards many other different companies. And the unique selling point of our product is will be the quality of the images as well as the cost effectiveness of the product compared to satellites. And yeah, so this is basically a basic SWOT analysis. I'll be explaining the one on the right since it's much more simpler. The strength of Geosol is that it's easy to use and that it's very eco-friendly in the sense that compared to satellites. And the weakness is that because we're using advanced technology, it's relatively expensive, although the benefits are much greater due to the alternative cost. Yeah, due to the alternative cost, because satellites are much more expensive. And the opportunity is that since this is quite a new market, there's a lack of competitors. But the threat is also that there's long production time and there's continuous R&D processes. Yeah, as well as a niche market, because our niche market is only a B2G as well as B2B, and it's sometimes difficult to find specific consumer goods. Yeah, so the uniqueness of Geosol is that we use drones as a medium to find factual data, and by using drones, we could basically gather much more data in a large, wider area. So next I'll be talking about. Oh, okay. Yeah, so I'll be talking about the materials. Basically, we need a lighter sensor, and we will be buying this through international suppliers. We need temperature sensors from local suppliers, camera unit from local suppliers, batteries from international suppliers, a CPU unit from local suppliers, and drones and transmitters from local suppliers. Obviously, we as the business continues to scale, the cost of drones will hopefully decrease. Yeah. Okay, so this is the financials for Geosol, including the prices of the hardware, the software costs, and the labor costs, as well as the operational costs. Since we want to be running workshops in Jakarta instead of factories, since using factories is much more expensive and costly. So our total variable cost is around $10,000, and our total fixed cost is around $1,000, and our selling price is $21,000. It may seem expensive because we have a markup of 111%, but because of the lack of competition, as well as how costly satellites are, we feel that this is quite appropriate because we could spend the rest of our money on R&D and to distribute the income among the employees. But obviously, if we don't get sales, we might decrease the price in order to increase the demand. But currently, our selling price is $21,000 with a break-even point of 0.12, meaning that for one sale per month, we'll be gaining. Yeah, we will immediately gain profits. And yeah, this is basically a timeline. We'll do planning, research, prototype production, testing, Q&A, invitation, follow-up, then we'll basically promote it to the public. So yeah, so our location, we specifically choose Jakarta because imports and exports are easier, and it's easier to find skilled employees near Jakarta, so it won't take it won't take that long for employees to come to workshops. And in addition, most of our suppliers come from Jakarta, making the distribution process much easier and quicker. And for the packaging, we use cardboard as well as wood to protect the drones from any damages. And regarding the technology, benchmarking must first be, we firstly need benchmarking towards authorities and experts, such as the Directorate General of New Renewable Energy and Energy Conservation, or the National Research and Innovation Agency for validation. Next, I'll be talking about the barriers to the market. Obviously, there's a high startup cost, and we do require venture capital since this is really advanced technology. There's obviously brand recognition challenges because when we search up Geosol, like other companies come up, many companies ranging from Spain or from the US, and we need high specialization technology or patents. For our marketing, we'll basically sell the products through direct sales, but we'll be using SEO or search engine optimization in order to optimize for, in order to make our brand more recognizable. And we'll also be using email marketing as well as special events in order to raise awareness and social media. Thank you.
Thank you. Now let's welcome our judges to give you questions. So first, Ms. Khalud, please.
Yeah, thank you. This seems to be a really big project and big idea. Who do you have on your side helping you? Do you have a team or?
No. I guess like teachers and parents, I guess. Yeah.
But perhaps you're gonna have someone to help you. This is a big project, needs a big
Yeah.
team.
We
You can do it.
we obviously need a chief technology officer and like CEO as well. People
Perfect.
working in different fields. Yeah.
Great. Keep going.
Thank you. Then, Mr. Wu, would you please ask him a question?
Yeah, sure. Did you come? You said you are going to collect the data from by drone. Did you have any data comparison between drone and satellite? The data you collected from your project, you said you collect them by drone, right? But the similar data can also be collected from satellite, right? Did you compare them?
Yeah, satellites are much more expensive, but I haven't actually compared both of the results. It's just with drone technology, it's much cheaper. It's a cheaper alternative rather than satellites.
Okay. No
Yes,
more questions from my side.
Yes, thank you, Mr. Wu. And then, Mr. Karthik, any questions?
So what is the motivation for you to work on such a large idea, such a big idea?
I guess the motivation is going to help because it's obviously going to help with pollution, right? It's going to help many companies, measure the amount of global warming and pollution within a specific area, which can really help businesses, with employee safety as well, and it can help many different industries, have a cheaper alternative rather than satellites. So that's like basically the main motivation because it's extremely environmentally friendly and it's going to solve a lot of problems for many different industries. I would say that's the main motivation for this project.
Thank you.
Thank you. Now let's give our judges 1 minute to write down their rating sheet. Okay, so congratulations, all the innovators. So you have completed our final pitch. Now it's the global celebration time. So we have 2 awards. Since this year, IFIC and ICIA has a collaborated online competition. So now the IFIC Awards will be on May 28th, 2022, and ICIA Awards will be held on April 21st, 2022. Okay, so remember this time, we're going to announce the awards. So now, judges, please join the breakout room for the judge review meeting. The students, you can remain here. Okay, so our judges are going to the breakout room to review today's meeting. And all of the participants, you've done brilliant today. You're real inventors and innovators of today, and you will be the problem solvers of the future. And thank you for coming. I'll see you on the awards meeting day. Thank you. Bye-bye.